So now I want to cover off what actually happens when we run an interaction. So we've prepared it, we've got our command directors, we know whether we're passing a results notifier in or not, whether we want to handle injections, but the command that you call on the interaction processor is run interaction. And taking a look at that, what is actually happening here? Well, we're passing in command directors to use. It may well be that we don't pass any because we want to inject them later on. If we don't pass any, then we'll use whatever setup, which of course might not be any at all, but ultimately what we want is a set of either a set of command directors to process, or that we're handling injections. And we'll see exactly how the injection handling works shortly. But for each of these, once we've got a set of command directors, we need to process them. And very similar to the interaction application where we saw it was following a queued message handler pattern, this is also following that queued message handling pattern, but it obviously doesn't have, this case, the results processing loop, because it doesn't need to process the loop. We've got the event loop handling events, naturally, and the main processing loop, which is handling the messages. Now, messages can come in the form of internal messages. Those can only be raised and managed by the framework. Our notification messages, and those can be used by the framework to send messages back out to the interacting application, for example, that we're done. Now, have a look at the process event loop. Again, we've got a while loop that runs continuously until it's told to stop, and the events that we're actually interested in, stop, pause, resume, done, injection, we register for, and then we're just waiting for any of those events to be raised. Here you can see the injection event, so if that comes in, we send a message on the internal message queue to inject. Pause, we want to pause, resume, and so on. When we're done, that's it. You know, the done event has been raised, the message, the interaction process has finished processing all the command directors, so we need to terminate handling events, and that's all that needs to happen here. Stop is a stop message. And we've just looked at injection. So each of these events is actually adding messages onto the internal message queue for the main loop to actually process. We look at this, you'll see again it's very similar. We've got a while loop that's running, and we're looking for messages arriving on the internal message queue and dequeuing them. And each of those raises a state within the main loop. Here, default as before, it could be timed out, or it could be an unknown message, which just results in an error. When we initialize, we're going to initialize the directors. Now, there's not really a lot for those directors to do, except for the time director, in which case it would remember the milliseconds value that it's starting at, so it knows how long that duration is. That's what initialize init directors is actually doing. It's just setting up those command directors so that they effectively know when they're finished. Process is to process all those directors, and we're going to come on to that. Continue processing directors, and you'll see why these states exist as we go through it. Inject, we're going to inject some commands. Done, we're done processing, so we should start tidying up. Pause the processing, resume processing, and these are fairly obvious. Stop, we're stopping, and exit is we're finished, and we need to stop the loop running and finish. So let's start to look at what happens with some of these states. So the main one obviously will be the process. When we receive the process message on the internal queue, it's going to run the subvi here, and this is obviously going to get to the guts of what's going on. So from our interaction process, we want all the command directors currently, and we're going to iterate over all of them. And the first thing we do is ask the command director whether it should continue or not. It will know whether it's finished, so if it's a one-shot command director, it will know whether it's processed all the commands once, in which case it doesn't need to continue. For a time director, it will know whether the elapsed time, the minimum amount of time has passed, in which case it shouldn't continue. But obviously, if it should, then we're going to go into this true processing to process that. Otherwise, it's got nothing to do. And on the true, it's going to process the commands. So for all of the commands of that command director, it's going to process them all. And if we've got a wait time, we also need to wait in between the processing of the commands. Okay. So when we've processed those commands, what's going on here is that this is all part of the data flow. Because those commands may have changed, we need to make sure that we keep track of the changes that have occurred for the command director and rewrite them back so that they get processed properly the next time. Don't forget that every time we reach a tunnel or we fork a wire, we are taking copy of data. So if when we call process commands and we pass in a director, it's a copy, and if we change it, we will never know unless we write it back in. And here we're saying when we've gone through and processed all the command directors, we need to, our next state is to continue, and we put that message on the queue and it routes round. Now I need to break these videos down so they're not too long. I'm going to come back onto exactly what happens with processing in another video. Let's go back and have a look then at what happens on continue. If we go to continue, we need to know whether we're done or not. One of the things we should check is whether we're handling injections. If we're handling injections, we're always going to be continuing because we can't finish. So if that's true, if we are handling injections, the next thing we do is process. So we set ourselves up to go back through that processing loop. Otherwise, we need to get all the command directors, and for each of them, just check again whether they should continue. And if ultimately it should, we need to then, the next state is going to be processed, so we go back to process command directors that need to be processed. Otherwise, if they've all finished, then we are done, and that becomes a state on the message queue. Coming back down here on done, what's happening here is we need to, on the notification message queue, so we need to tell the application, the interacting application, this one that's running here, that the framework has done, that we've processed all the commands, so that gets enqueued, and we raise a done event, and we tell ourselves, the framework, that we need to stop. We're back in here. And stopping is all we do is we tell the framework itself to exit. Cue that message up. So the next state from stop is exit. And here I'm just keeping the same pattern established within the state machine for continuity purposes, to make it clearer to understand exactly what's going on. And here we're exiting the process, and we are, each of the commands we iterate from the command directors, and each of the commands we're telling the commands to clean up. So anything that needs to happen within a command that the application itself has created can be carried out. So the commands themselves tidy up themselves in a nice clean fashion. And then we are stopping the processing loop, not forgetting that the event loop stops itself. And that way we've processed all the command directors, we've told the interacting application that the framework has done, that all those commands have been processed, and now the interacting application can take back over and do whatever it needs to do. And this is I'm going to close this video here now before we go directly back into the processing of what's going on there. Otherwise it's going to be too long, but hopefully that gives you a view of how that state machine is running within the framework, and we're iterating through those command directors, knowing when they're done and continuing that processing until that has actually happened. To handle injections, there's an example which I'll run through in a lot less detail than this one, showing exactly what's going on there, but all those injections are actually being added into that queue, so effectively we're increasing the set of command directors that are being processed. Hopefully that's clear enough now, and until the next video where we'll go through the processing